been over 40 years I've been doing this, so it's like there's kind of a lot to try to condense, and so I apologize if things go a little too fast in some places, but hopefully you've picked up some of it already. Please stop me and ask any questions. As we get to it, we'll try to get through. I think I got about 70 slides, got 90 minutes, so we'll see if we can get through it all. The question is, everybody here a double E? Or let's say, who's not a double E here? Anybody? What are you? Mechanical? Civil? Okay. I got relatives who are civil. I don't know about mechanical, but so a lot of what we talk about is certainly energy related, and there'll be a few points where I'll even ask you to kind of challenge your thinking about electrical engineering, and I'll get you thinking about it right now. It's like, what exactly is energy? And we'll kind of go into that, which I think makes the discussion kind of difficult because we do live in kind of an abstract world, but sell a kind of a useful product. So to make things maybe more interesting for me than for you, I've got a few questions I want to ask, see what you kind of know and understand. Unfortunately, most of it is probably all before your lifetime started, but bear with me here. You don't have to shout out who your electric supplier is. Who in the room knows who they buy electricity from? Who doesn't know? Maybe it's an easier one. Are you on campus or something?
No, I'm off campus, but my apartment takes care of the bill. Like I don't see who.
You don't see a bill? So for people who actually get a bill every month and don't know who your electric supplier is, the reason I ask it, when I worked at Gainesville, GRU, we would send out surveys. 40% of our customers didn't even know that they bought electricity from GRU. And it kind of relates to the market aspect of things that are near and dear to Sean and my heart about how people are going to respond to their electric bill and stuff. It's like, boy, if you don't even know who you're buying it from. That's an interesting thought. Again, our survey back then was 40% didn't know. Do you guys have a clue how much electricity you use per month? Kilowatt hours? Anybody take a guess? I heard we had some electrical engineers in the room. You get a bill, you don't know what's, okay. Not a trick question, but do you pay more? And I mean on average, I don't mean what your total bill is. You use more electricity in the summer. I'll give you that you figured that part out. But on average, do you pay more in the summer than you do in the non-summer months? Why would you?
I keep my AC off.
Well, it's not a volume thing. Again, the average rate that you pay is your rate higher. It's like a gallon, it's $2.38 a gallon of gas. Does it go to $3 a gallon of gas in the summer? The answer is no. It doesn't in Florida. So you don't really use more. We could get into some nuances of rate design and stuff, but I bring these up because these are some of the things, some are challenges for how do you design a market where customers respond when they don't know some of this. And I've struggled my whole life for 40 years just trying to explain to family members exactly what do you do and what is this thing. And I marvel at the fact that if we were in any business other than energy, everybody would understand, I think, everybody would understand the product that we sell. If I worked at a shoe store, people could tell me all kinds of things about shoes. People can't tell you about energy. But then the worst part of it is there's many politicians and other people today that claim that they're experts in energy, and they really don't know anything. What energy crisis occurred, and these things do have relevance to the changing of the markets occurred, so I'm not being completely goofy here. But what energy crisis occurred in the 70s? I know it was before your time, but you might have read. Any guess? Anybody know what happened in the 70s? Nobody?
Was it the black ring?
No.
There was something from 42.
Oil embargoes. First in 1973, due to a few countries, probably not in the news today, Israel, Syria, and Egypt had a little conflict. OPEC, you guys know what OPEC is? Organization of Petroleum Exporting Countries. They embargoed the United States and everybody who supported Israel. I'm not trying to bring in the politics of it. But what they did is we had an oil spike. Oil used to be $3 a barrel. Anybody know what oil is today?
$50.
50, 57 maybe is the last number I saw. Back then it was $3 a barrel, went to $12, freaked everybody out. It happened again in 79 when there was another oil embargo that occurred. What it did is it really changed and started to influence what was happening in the energy space. And I'll go through some of the history here in a minute. But it's really very much that energy, electricity was so cheap. We used oil. We used a whole lot of oil. Like I said, I started at the utility in Jacksonville, and my first day on the job, they were hanging the board chairman in effigy outside the front door because electricity rates had gone up so much because of these oil embargoes. So I started in 76 at JEA. What is WHOOPS? Anybody hear of WHOOPS? This is a little more abstract. The Washington Public Power Supply System is what WPPS. Anybody from the Northwest? Is everybody kind of... another kind of a seminal moment in the development here. These were five. This was a public power group, which means city government types that were building nuclear plants in the Pacific Northwest. And that was back when I started my career. Utilities were growing at 15% per year. Today it's about 1, if you're lucky. Some are 2. And so they were building nuclear plants, and they went bankrupt, and it was the largest default in the history of the United States at that point. $2.25 billion. People who invested in that lost. I think the Orange County Pension Fund is a bigger default these days. But it was the kind of mistake that people said, this isn't right. You made a stupid bonehead decision. In retrospect, what they claim, you built these things, it was mismanaged, but it's the customers that have to pay for it. The world has to change because of that. So that's why I bring it up. I really didn't expect you guys would know that, but I thought it important to kind of say, well, what were these things that caused the markets to start to change later in my career, but before yours even began. So it's all a matter of perspective. Closer to home, at least we're close to maybe a few birth dates in the room. What was the California energy crisis about? Anybody know? And I'm not trying to put you on the spot. I just curious if maybe you've heard about this one, don't know the details. Well, as I'll talk about, the markets began getting re-regulated, kind of changing how things worked in the 1990s. California adopted a few schemes to do that, and real bad things happened financially. They made utilities sell off their generation, so they had the responsibility to serve load but no generation. It happened to be a bad period. They get a lot of electricity from the Pacific Northwest. A lot of snowpack goes through hydroelectric dams. So they had a lot of physical limitations, and they had a market design problem that opened the door for people like Enron. Have you heard of Enron? You guys really are too young. These are all interesting things in the energy business. Enron, for a while, might have been the largest as far as measure of capital in the world. And they completely went defunct in a matter of months because it was all a scam. But they got caught up in the California energy crisis. Basically what happened is because of abuses, poor design, California not approving transmission projects, power plants, a lot of bad things happened. Electricity prices went from like $50 a megawatt hour to $5,000 a megawatt hour. People went bankrupt. A lot of it was the design of the market, which is kind of some of what we're going to talk about today. So I always like this expression when I eventually finish a dissertation. Will be on my first page unless Sean makes me remove it. Thomas Sowell is one of my favorite guys. He is an economist, and you may hear me say things throughout today that I don't typically care for economists because I think they're messing up the markets. But I think that's a perfect example of where kind of the history of what's been going on in the energy market is we replace something that worked and worked for 100 years with something that people think sounds good. And I kind of throw that out. I know all of you guys, what you may do after you graduate, go into different businesses. Always be kind of cautious about that. That things may sound awesome. The question is, to me, I think it's up to engineers to figure out, is it really awesome? Does it make economic sense? Does the math work out? And there's so much you hear about today that it doesn't. Give you one example. My pet peeve is rooftop solar. If you like solar, you put it in a field somewhere because it's 1/3 the cost of putting it on your roof. But people love to put it on the roof. And if you want to put it on your roof, and that's your decision, fine. But as a utility, you should encourage putting solar out in a what they call utility scale. And it's a 3-to-1 difference. I mean, it's significant. And so Gainesville has 18 megawatts, I think, of solar, a lot of it rooftop. And it costs 10 times as much to produce that electricity as it does from other means. So that's some of the stuff that I talk about. So let's talk about the history. I always, for some reason, like to think it's important to kind of talk about from where we came. And as you do think about some issues, some things I assume you've heard about in here, parenthetically, I put in the word microgrid. I don't know if you guys have talked about microgrids. Have you heard about those? Really a small isolated system. I know a lot of military installations are starting to go that more for resiliency, to say, well, if something bad happens, a hurricane comes through, at least we have power type thing. But start from the very beginning. Early electric generation, what they call dynamos, that was always a name that confused me for years. It's just a DC generator. They served isolated loads. I mean, that's how the industry got started. Had to throw up the name Faraday, since I know you all know who Michael Faraday is. They used permanent magnets. You know, you can still buy a permanent magnet motor today, DC motor. You can find a permanent magnet DC generator. But one of the problems was they couldn't make them too big. I guess these permanent magnets had to be huge. And it wasn't until Siemens and Wheatstone invented the electromagnet to go with it that could then make it at a much bigger scale. So that was kind of fundamental as to what started, call it the power industry, but I'm not talking about a grid of connected things, just power plants that were serving loads. Have you heard of Siemens? Siemens, a German company, pretty big outfit. Wheatstone, I don't know what happened to Wheatstone. Siemens created a company that's still in business today. So they had these power stations developed in the US and Europe to serve just local specific loads. Kind of made sense how it was. I know electric trolley cars were kind of one of the earlier users of it. They'd have a generator or a few generators, and they would electrify just that part. So it wasn't a utility system like we think of today. And so I always like to point to this. Has anybody been to St. Augustine? Do you know what that is?
It's the school.
That's used to be the Ponce de Leon Hotel from 1888. Henry Flagler. Kind of important to flag. I know this isn't a history class, so just bear with me. But Henry Flagler was pretty instrumental in establishing Florida, doing a lot. The East Coast Railroad. He worked with at Standard Oil Company, very wealthy guy. He created this resort for his friends. If you haven't been there, it's really quite cool. One of his friends was Louis Tiffany, and in that is the largest collection of Tiffany stained glass in the world. Kind of cool, if you like Tiffany glass. I think the church over here is where he's buried and all, and that has a nice collection of Tiffany stained glass. But another one of his friends did something else for him, and that was to build that. Anybody know what's behind there? That's the remnants of a power station. Used to have dynamos, they don't have them anymore, that his friend Thomas Edison built for him back in the 1800s. So this was the kind of the application as to where it started. Now, I'm kind of maybe overemphasizing this as a little bit, is one of the things you'll hear a lot of people talk about is microgrids, and we need to get away from the big bad utility. At least it was something I wanted you to think about, that as the industry started, you started with microgrids. We moved away for a reason. I like to think it was a sound reason, and I'm not saying there aren't reasons to move back. I'm just saying if you go back, there should be a reason, not just, oh, this is awesome. This guy just came up with this awesome idea. It's called a microgrid. Let's go do it. And it's like, well, no, that was a microgrid right there. So when you first started creating the utility concept, people point to the Pearl Street Station in New York. Interesting, they don't have a photo of it. The only thing they have is an artist rendition. But this was, in a sense, the first power station that served a broader area. It was maybe a dozen blocks of Manhattan. I don't think it was very much. A Thomas Edison plant. I think it was coal-fired. So that was kind of the start of the utility-ish looking thing. It wasn't just serving a dedicated load. It was serving a lot of different things. But it was more when Commonwealth Edison, there were so many things happening at this time in the US and across the world of people using this technology. It's kind of hard who got there first, you know, who landed on the moon first, this kind of thing. A lot of battles. But Commonwealth Edison was just kind of one of the pioneers in developing a transmission system. If you've watched it or know about the War of the the current wars, whatever they call the movie out. I haven't seen it yet. I need to, but obviously that battle was being fought. You weren't going to get to a transmission system until you really got to AC power and had transformers that were cost effective to build and could step the voltage up. But a lot of that started with Commonwealth Edison, which, if you don't know, is the utility still today in Chicago, kind of where they started. And some of the key players that were in here, actually I learned just preparing for this class, not that I'm a complete history nerd, but Robert Todd Lincoln was on the board of directors of the Chicago Edison Company. So Abraham Lincoln's son was there. I didn't know that connection. The last name, though, was Samuel Insull, and so he was kind of the father of the power grid, at least in some people's opinion. And so it really developed this growing of transmission lines, distribution customers back in that time. Utilities, they would sell, they didn't have a demand for their products, so they would sell that too. They sold irons, they sold maybe electric washing machines. Gotta stop yawning, Sean, back there. Stop yawning. I'll get to more exciting stuff here soon. But I'll point out that at the time that this all started in 1892, it was only 3.2 megawatts. And I'll throw out a lot of megawatt numbers. I know it's probably hard for you guys to know what is a big number and what's a small number. Gainesville's peak load is about 500 megawatts, would be my guess. The state of Florida's peak load's about 30,000. I think the United States might be around 600,000 or 700,000 megawatts. Back then you had about 3.2 megawatts, so a lot of growth during that period. But this is the type of system that kind of grew out of what all these people were starting and what Commonwealth Edison started. I hope that all of this is pretty familiar to you, but I kind of didn't want to skip over it. One of my questions, if I had more time, was, can you explain to family and friends how electricity gets to your plug? And then this is kind of the whole thing, what all the moving parts are. Power station typically generates at about 13,000, maybe 20,000 volts, stepped up to high voltage, moves around the world, certainly moves around North America. You step it down as you come into neighborhoods and eventually get down to your 110 volts at your house. So if you have questions about that, we'll talk about it. I wouldn't say more. Other than most of my discussion about is really what's happening up in here, which is the wholesale market. When you get down in this area, you're talking about the retail market, which today is still pretty much a purely monopolistic thing. People have service territories. If you want to buy electricity, you buy it from them. But up in the world, it should be clear, either in things you've already heard or things I'll say today, that kind of talk about that market that exists of people buying and selling electricity at that higher voltage level. Become what I am, which I tell friends I'm a used megawatt salesman, is what I am. So again, we started with local systems. They grew to utilities, starting serving regional areas, if you will, maybe a city, and they eventually, well, before I was jumping ahead here, so they grew to utilities serving larger areas. We'll talk a little bit about some federal agencies that were formed. You've probably heard of TVA, the Tennessee Valley Authority, Bonneville Power Administration, Southeast Power Administration. These are getting more obscure. They were there for hydro projects, but they make for nice generators. So they would build generators. So they are a participant in this market, don't serve customers. And from day one, kind of looping back to Flagler College, it's not a generator today, but it could be in theory. There are still, there were facilities back then that did their own generation, and there are still a lot of facilities today, customers, some people that I work for, and kind of manage their facilities. They still self-supply because sometimes it makes economic sense. This is not much detail for you to understand, but this is kind of what the network in the United States looks like, of predominantly AC transmission lines. We'll talk about DC in a little bit, but most of it is just, and these are the high voltage lines. Didn't realize till this morning, it shows it going up to 500,000 volts. There's actually parts in Ohio that are 765,000 volts. But those are kind of the typical voltages. If we were to throw up a map of the United States of natural gas pipelines, it actually would look a lot like this. And I think one of the significant things of the state of energy in the United States is we have a lot of infrastructure that allows us to do a lot of things. when I hear people, I think of it as if you're hearing about fracking, and we've developed a lot of fracking, it's really made gas cheap for us, but why it's worked is because we have pipelines to get it someplace. There's other parts of the world, it's like, well, why don't we just show them how to frack, and then won't the world be better? It's like, well, they don't have pipes, and it may take them 30 years to get pipes. So it's kind of important that you have the infrastructure to do it. One of the things that wind struggles with a lot is the transmission lines were not built to where the wind generators are. So even with all of this network, if you notice, there's a ton of wind right here in western Kansas, but you don't really see a lot of transmission lines. Why don't you think there's transmission lines today in western Kansas? Anybody been to western Kansas? There aren't people out there. There's some farmers out there. I've been to western Kansas. So anyway, so transmission is kind of important in how this all comes together. Something to understand is that these are a synchronous grid. Have you guys talked about that? Again, I recognize I may go into some things that the relevance may not be all that keen. We operate at 60 hertz in the United States, but it's more than you're just operating at a certain frequency. You're also synchronized. But in the United States, really North America, leave Mexico out for just a minute, there are 3 interconnections. And what that means is they are all synchronized within those interconnects. They are connected, that I'll explain in a little bit, but they're not synchronized. The West and the East are not synchronized. Do you know how they're connected from East to West? They use DC power lines. Anybody know why they use DC power lines? Which I've got 7 of them here. Well, in order to operate, they don't operate at different frequency, but they're not synchronized, meaning they're not peaking at exactly the same time. And if you've kind of gone through power flow equations, I say that a little bit loosely, there's got to be a little bit of a phase difference for power to flow. But put that aside, you say, no, it's like the voltages are all peaking at the same time. It's a stability issue. It's a distance issue that you can't, it's a little more abstract, but you can't interconnect these 2 big masses and basically have them swinging with a small little line connecting the 2. If you see, let me say one more thing. If you see, they're all about 200 megawatts. And I said the United States is 600,000 megawatts. There's not a lot of capacity east to west. But if you own the rights to move over that, you can become very wealthy, arbitraging the price from east to west. Yes?
I'm just curious. I see that you left out Alaska for the transmission stuff. Any comments on that?
I couldn't remember. I don't think that they are synchronized to the Western Interconnect. I think they would operate their own system. There are maps I'll show that actually show that the synchronization goes up into Canada, but I don't think it reaches Alaska. I think they operate as a separate isolated system. Also point out that this part of Mexico is also synchronized with California, operates together. I meant to add here, but there are some DC lines that connects us to Mexico here, a couple of DC lines up to Canada. Even though they operate synchronously between us and the Canadian eastern part of Canada, it's still a stability issue. Again, kind of beyond the scope of this discussion or your class. But they also have some DC lines in California from the north to the south. If you really want to efficiently move a lot of power over a large distance, they can do that better with a DC line than a large AC line. So there's a couple of reasons, but it doesn't deal with the synchronization. So again, I'm kind of bringing this up because I think you've been taught about balancing authorities, area control areas, the droop, all that math that goes on. It's done within each of these 3 areas. Maybe the final point, why is Texas separate? Why does Texas have its own interconnect? Anybody from Texas? Anybody know anybody from Texas? Think of that personality from Texas. They don't, and I'm not kidding here, they don't like to be told what to do. The wholesale markets in the United States are regulated at the federal level because of the Commerce Clause. that any kind of activity that goes from one state to the next has federal jurisdiction. Well, if you put a DC line between here and there and here and there, you'd say, there's not Kirchhoff's laws. These aren't mysterious megawatts flowing around here. I am separate. So Texas is not federally regulated, and that's why they're separate. So I always have to throw that in. I don't dislike the people from Texas, but there's an attitude in the people from Texas. Industry players, whenever I talk about this, it's the idea that there are so many, I don't know how many different utilities I bought from in my life, but we kind of started with the talk about you don't even know who the players are. So let me go through this quickly. But there are a lot of different ways that we skin it here in the United States. Other countries, I'll make some mention to Mexico. It has one large utility. It's called the Federal Commission of Electricity, the CFE. And in France, they have EDF, the Electric Utility of France. They have one utility. It's like if you're familiar with Florida Power and Light, they're the largest utility. It's like, no, you just had one utility in the whole country. A lot of countries are like that. Canada's not like that. But we are so different. There are so many different ways that you can create a utility. They're investor-owned, which means stockholder-owned. Municipal utilities, electric cooperatives, kind of how they all got created is investor-owned utilities started, like Commonwealth Edison. And it wasn't cost effective for them to go to some small city. So small cities like Gainesville didn't have electricity at around 1900, so they made their own. After that was done, there was nobody serving out in the rural areas of the country, so they had a federal act that was passed to do that. So there's a lot of different ways that you can make a utility, and all of them participate at the wholesale level. The exception being what I've called other. Maybe you've talked about retail service providers. People sell at retail. We don't have electric competition. Have you guys followed, there's a local company, Infinite Energy, here in Gainesville, wants to give us, oh, you don't know them.
I've seen about it.
They want to provide retail competition. They want the state to have retail competition in Florida, which means that everybody could buy from whomever you want. It's like your long-distance carrier. Your wires will still bring it to your house, and that would still be like GRU's wires or Clay Co-op's wires if you're in the suburbs or the outer areas of Gainesville. But the power part of it, like the long-distance part, you would buy from anybody you want to. They do that in Texas, Michigan, Ohio, but most states they don't, mainly because it turned out to be kind of a mess. But that's what they're promoting here. And in order to get the retail, you need the wholesale. And we'll talk about the wholesale isn't set up in Florida to do the retail, so it's stuff that they're pushing. There's also independent power producers, which are some of the companies that I work with. And I'll talk about how they came to being, but they're just private entities, own power plants, and sell power. There's also industrial facilities. Again, harking back to, that's how it all started, is people having a need and generating themselves. We work for Tropicana. They have a orange juice plant down in Bradenton. They have their own generator. They make steam and electricity. What they have left over, they sell into the market, or we sell that for them. Some other names of here are the people that also do that. Any golfers in the room? Mosaic owns Stream Song, awesome golf course here in Central. Students don't have time for golf? Is that what it is?
More like money.
Money? Well, you're going to be in the energy business. If you ever get there, you got to play golf. So, quickly, some of the layout again as to, well, who are the players in the investor-owned utilities? There are 4, and that is because Gulf Power, the yellowish one up there, was bought by Florida Power and Light last year. So up there in the northwest. Used to be part of the Southern Company system up in Georgia. You see FP&L serves all around here, Southern Third Net. You've got Duke Power, and you have Tampa Electric Company. You have a little company here called Florida Public Utilities that serve here and there. It's actually pretty small with about 27,000 customers. Gainesville, I think, is about 80,000 customers. So it's not a very big investor-owned utility. Municipal cities are allowed to create their own utilities. Again, anybody can become a utility is kind of the theme in America. Most of these are probably over 100 years old. They were all started because the big bad IOUs would not electrify their neighbors, and they started. Now the IOUs wish all these people would go away. They claim that they can do it better. Florida Power and Light is looking to buy Jacksonville's utility. And Jacksonville is an extremely large municipal utility. They're at 5,000 megawatt utility. Cooperatives, there's a lot of overlap here. The cooperatives mainly serving the back areas. So again, it's just what some of the players are that are in the industry. So if we talk about, I'm going to shift gears here a little bit and talk about power system operations. Things I'm sure you've talked about. The load is pretty constantly changing. Generation is controlled to maintain the power balance, your area control area. Again, I'm assuming you probably went through some of that. Maintain the voltage. And you have balancing. Now, I do know you were told about what a balancing authority is. The authority might be the entities that's responsible for making sure everything stays balanced. A balancing authority area or a control area is maybe the region where they have authority over. And I think I have some Sesame Street versions to kind of show you how that is. I didn't want to bore you with silly equations with Lagrange multipliers that you may have seen. But I do use this to explain to family and friends, well, what is a balancing authority? If you were a solo system, it would simply be customers pulling water out of your reservoir, and your job as the utility is to make sure you keep enough water in it to maintain that red line. In my incredibly simple terms, that red line is like your frequency, trying to hold that at 60 hertz. If you had two systems, you have two people trying to maintain the balance, trying to maintain the level at 60 hertz, and in between you're buying and selling the power between the two. So I was tempted to delete this because it was goofy what I did before, but I thought I'd share it with you. If you ever need to explain people, what is a balancing authority? There's Bob's Big Bird explanation of what control areas, balancing authorities, kind of synonymous terms. Another way to look at it, and this is out of a presentation from PJM that I'll talk about. I don't know if you've mentioned the names of specific regional transmission organization, but it kind of shows that, this whole objective of a balancing authority is just make sure that the megawatts all balance up, or what being demanded on the system versus what's being generated or imported, and making sure you maintain the frequency level. And I couldn't leave it without at least showing a picture of what, now this looks a little less Sesame Street version. This is the control center at PJM. We'll talk more about that in a few minutes. But this is a room full of people whose responsibility is to make sure that the lights stay on, that everything stays controlled, lines don't overload, units trip offline, they make phone calls or send computer messages. So it's kind of the brains behind the RTOs. You guys, you've heard of an RTO, right? And an ISO?
Original.
Another trick question. What's the difference between an RTO and an ISO? I'll ask Sean. I bet Sean did.
Yeah, fast forward.
We'll talk about that later. Okay, how long do you want me to go before we break? 50?
All the audience.
50? 50 minutes? Is that what it...
So your total time is like 90.
I mean, 2 classes, 50 and then a break and then 50? Or do we just go 90?
If we ask for a break, they always say, keep going. So
Oh, so you want to get out early? I'll go about 10 more minutes and I'll just need a drink of water and we'll get going again. Power markets. There's 2 general things that I've been covering, will continue to cover, and it's touching on kind of the physical operation things. How do we get the megawatts flowing? How do we maintain frequency? That, which is the responsibility of the system operators. And then operating market. So I kind of say it slow to make sure it kind of sinks in, because it is kind of an odd thing. And I'll use the example. It is, you're operating a flea market for electricity. I mean, you're creating, the economists who get into this say we really need competition. We need everybody to be able to compete fairly. But we want to sell electricity, using a more generic word, electricity, in these markets. And we're going to talk about some of the products that you're buying and selling. So again, it's kind of maybe be a parallel path of, and I may just go back and forth in a confusing manner between what some of the physical things are and what some of the market things are. But let's talk about this. So traditionally, and you notice I list 100 years, utilities just generated power to serve their own customers. They balanced the power within their system, again, kind of the physical thing. And to the extent they did a market function, they would pick up the phone and call their neighboring utility, and that's an important thing I'll emphasize here in a minute. They would call their neighboring utility and say, you know, well, I say when economical. I was going to turn it into a question, but it's like they would pick up the phone and call their customer and says, you know, I've got an extra 100 megawatts, and I will sell it for X. Are you interested? And they would say, well, as a matter of fact, that's cheaper than what I can generate myself. So yes, I'll do that. And so they would do what are called bilateral transactions. One of my favorite examples of this, anybody been to the Biltmore House in Asheville? One? Do you guys like get out? You guys... Okay, Biltmore House. Have you heard of the Biltmore House? If you get a chance, it's a beautiful house. It's a massive mansion built by the Vanderbilts. Anyway, it's a beautiful thing. But they had, not surprisingly, rich people, they had a generator. It was a house built in about 1890, and they had a generator. Had an elevator too, which was kind of cool, I think, for 1890. But they have a dynamo down in their basement. And when I was there looking, reading about it, it's got a plaque, and it mentioned that they started like in 1890, maybe it was around 1900, I don't know exactly when they were doing this activity. They discovered that they had surplus to sell at certain times of the day, and they built a line to go to the city of Asheville, which wasn't too far away, and they would sell them power in the middle of the night. So it's like they had a market back then. Just whoever's idea it was, they said, hey, how about if we just connect our two systems? So that's kind of how it started, pretty simply, but a very human, it took a human to pick up a phone and call and make that market happen. So, and back during these periods, there was always these variants, if you say, of a market, is to say people could always self-generate. Again, they did when it started. They still do today. At least throw out as far as the markets that, well, let me back up. But